Hello. Hello, good afternoon everyone. Today I will going to start the concept of Lorentz force, which is a support of in magnetic effects of current here. Okay. So what is the Lorentz force? Suppose consider electric field है बेटा, ऐसे electric field. This is an electric field. This is an electric field. The electric field would be like is there. This is an electric field. This is an electric field. Okay. Electric field I am creating by applying what is that? A external source, right? This is an electric field. For the first plate I have given positive charge and second plate I have given negative charge. So the direction of electric lines of force will act from positive charge direction to negative charge direction like this. Okay, positive charge direction to negative charge direction. Next I did apply a magnetic field here beta. This is a magnetic field and magnetic field also provided like this across the electric field. This is a magnetic field. A magnetic field has provided across electric field like this. So the magnetic lines of forces will acting what is that from north pole to south pole direction. These are the magnetic lines of forces. Okay. Suppose consider a charged particle beta. This is a charged particle. This is a charged particle has a mass m and charge q, which is projected between the two fields like this, okay, with a velocity v. So on the charged particle, when it is enters across electric and magnetic field, this is a magnetic field B hai, this is electric field E, this is electric field E. When the charged particle of charge q and mass m enters in crossing the electric and magnetic field, the charged particle can be experienced as the force in the electric field. The charged particle can be experienced as the force in the electric field. Okay. Next, the charged particle experiences the force in the magnetic field. Okay. So how much amount of the force experiencing see here? The force experienced by the charged particle in the electric field would be equal to how much beta? This is an electric field. This is electric field. The direction of electric field would be acts from positive charge to negative charge direction. When the charged particle is enters in this, it would be experiences some amount of the force. How much amount of the force it will be experiences? So the force experienced by the charged particle in the intensity of electric field is given by E is equal to F upon Q. F upon Q है बेटा. From this F is equal to EQ हो जाता है. This much electric force it could be experiences. Okay. When the same charged particle is enters into the magnetic field, let's take magnetic field. What is the magnetic field? This is a magnetic field. North pole है बेटा वो north pole and this is south pole. I am drawing like this direction. The lines of forces will acting like this direction. Okay. When the charged particle of charge q and mass m which is enters into the magnetic field of induction B, it would be experience the force. What is that? F is equal to F is direct proportional to Q है. चार्ज ज़्यादा रहे तो मैग्नेटिक फोर्स ज़्यादा रहते एंड डायरेक्ट प्रोपोर्शनल टू V है. वेलोसिटी ज़्यादा रहे तो फोर्स भी ज़्यादा रहते एंड इंडक्शन ही है. दैट इज F इज इक्वल टू व्हाट इज दैट Q इंटू V क्रॉस B हो जाता है बेटा. V क्रॉस B V क्रॉस B व्हेन इट इज एंटरिंग मेकिंग सम एंगल थीटा हो जाए तो क्या हो जाता है बोलो. F इज इक्वल टू और FB इज इक्वल टू QVB into sin theta. If theta is equal to 90 degrees, what happening is that the magnetic force acting on the particle is given by F is equal to Q into V cross PA और QVB हो जाते हैं. F is equal to Q cross B, that is equal F is equal to Q into V cross B हो जाता है बेटा. Q into V cross B हो जाता है. This is a magnetic force. So Lorentz was studied these two forces and he was given one statement. When the charged particle is enters into the magnetic field of induction into the across the electric and magnetic field, they are acting mutual perpendicular to each other. Therefore, the net force acting on the particle is given by what is that? electric force would be acting, the positive charge particles experience the force in the direction of the field. ऐसा act करते हैं. So magnetic force which is acting along the direction है बेटा, and electric force will acting along the direction like this. So the net resultant force of these two forces will act like this direction beta. That is, the net resultant force acting on the particle is given by F net would be is equal to, what is that? F net is equal to Fe plus Fb. Magnetic force plus electric, sum of the magnetic force plus electric force both will be equal. So what is the electric force? Electric force is nothing but QE hai. That is F net is equal to, what is F net? F net is equal to what is F net? Fe means EQ plus Q into V cross B. Magnetic force is a Q into V cross B hai beta. So from this F net is equal to, what is F net value? F net is equal to Q into E plus V cross B. This is called as a Lorentz force. When a charged particle is crossing the electric and magnetic field, okay, the net force acting on a particle is equal to sum of the electric force plus magnetic force. So this force is called as a Lorentz force. Okay, is it clear? Lorentz force means when a charged particle is enters both in electric and magnetic field, what happening is that it would be experience the force in the direction of electric field and magnetic in the direction of the magnetic field. So the sum of the two forces acting on the particle was explained by the Lorentz, that is equal to F net is equal to Q into E plus V cross B, where E is called as an intensity of electric field and B is called as a magnetic field and V is nothing but a velocity. Is it clear? Is it clear or not? Respond. Is it clear now? Okay. Next, see, when the charged particle is enters across the electric and magnetic fields, okay. Suppose consider a charged particle hai beta. Charged particle enters like this. Electric field, I say this is an electric field. Direction of the intensity of electric field will acting along the direction like this. This is the direction of an intensity of electric field. The direction of intensity of electric field acting like this direction. This is a positive plate and this is a negative plate. I have created, what is that? An intensity of electric field like this. Okay. I have created an intensity of electric field between this positive and negative plates beta, which is acting downward direction. And magnetic force, what is that? The magnetic field also, south pole, north pole is placed here and south pole also here placed. Okay, south pole is placed here. Due to that, what happening is that the magnetic lines of forces will act from the north pole direction to south pole direction. Okay, when the charged particle is projected, when the charged particle of charge q and mass m, which is projected like this with a velocity v, if it could not be deflected in any field direction, then if it could not be deflected in any field direction, it could not be deflected in electric field direction or magnetic field direction, then what happening is there in this case? The force, when it is possible, when a force acting on the electric field on the charged particle would be is equal to, when the force acting on the magnetic field on the charged particle, then the charged particle could not be deflected in any field direction. So in this case, the magnitude of the electric force Fe, which is equal to magnitude of the magnetic force, both will be equal. Okay, magnitude of the electric force is equal to magnitude of the magnetic force, both will be equal. So what is the magnitude of the electric force? That F is equal to EQ, no? EQ is equal to Q into V cross B will be equal. On both sides, what will be gets cancelled? Q gets cancelled here. So from this C is equal to, what is that? V cross V into B. That means when the charged particle not deviated in any field direction, when the charged particle when the charged particle not deflected not deflected. Then what happening is that Fe is equal to Fb. So in this E is equal to, what is the E is equal to V cross B. Okay. Okay, electric force and magnetic force will be equal. So based on the concept, see one problem, see JEE मेंस प्रॉब्लम है बेटा, वो प्रॉब्लम देखो एक बेस्ड ऑन दिस कॉन्सेप्ट. प्रॉब्लम देखो इधर जेई प्रॉब्लम है बेटा, जेई प्रॉब्लम देखो. ओके, सपोज कंसिडर ए इलेक्ट्रिक फील्ड एंड मैग्नेटिक फील्ड्स which are acting mutually perpendicular to each other like this. Okay, the electric field is acting along the direction, this is the direction of electric field. Okay, the direction of electric field acting like this direction, downward direction है बेटा. ऐसा क्रिएट करो, सेम प्लेट्स लेके क्रिएट करो. Suppose electric field has to be created like this between the plates of a capacitor like this. Okay, electric field has created like this between the plates of a capacitor. What is the direction of electric field? From positive charge direction to negative charge direction. Next, magnetic field is created along the direction like this. The magnetic field is created, this is the north pole and this is a south pole. The magnetic field is created perpendicular to the इलेक्ट्रिक फील्ड डायरेक्शन है बेटा, ऐसा इलेक्ट्रिक फील्ड डायरेक्शन है. ठीक है, ए चार्ज पार्टिकल ऑफ चार्ज क्यू है, इसका मास है हमें, विच इज प्रोजेक्टेड विथ ए वेलोसिटी ऑफ v इज इक्वल टू, व्हाट इज द v इज इक्वल टू 2 into 10 to the power of 5 meter per second, 2 into 10 to the power of 5 meter per second. Then charge particle is moving along this direction. Okay, when the electric field is switched off, the charged particle is moving in a circular path. When the electric field is switched off, the charged particle is moving in the circular path of radius कितने बेटा, r is equal to 2 centimeters, that is 2 into 10 to the power of minus 2 meters. Then find the magnitude of the, what is that, find the magnitude of the, what is that, magnitude of the electric field. So इसमें इनिशियल में कितना इलेक्ट्रिक फील्ड अप्लाई हो गए है वो भी निकालना पड़ता है. फाइंड द मैग्नीट्यूड ऑफ एन इलेक्ट्रिक फील्ड है बेटा. ठीक है, ए चार्ज्ड पार्टिकल यू कैन टेक प्रोटॉन, देख दिस प्रोटॉन so proton, a proton of mass m and charge q is projected with a velocity of 2 meter, with a velocity of 2 into 10 to the power of 5 meter per second across the uniform electric and magnetic field. Okay, then it would be moving with certain velocity. When electric field is switched off, then what happening is that the charged particle is moves in a circular path of radius r is equal to 2 centimeters, that is 2 into 10 to the power of 2 into 10 to the power minus 2 meters. Then find the magnitude of the electric field. Magnitude of electric field कितना रहता है वो भी निकालना पड़ता है. ठीक है, already know when a particle is enters in a circular path of radius r, what is that, r is equal to mv upon qb is already know. Is it clear? The radial path would be is equal to r is equal to mv upon qb. But when the electric field is switched off, it could not be deviated, it could not be deflected in any field direction. When E is equal to switched off, when E is equal to switch off, it could not deflect in any field direction. It could not be deflected in any field direction. It could not deflected any field direction. Then find the magnitude of intensity of electric field, how much? Okay, that was the question. See here, R is equal to mv by qv hai beta, but B is equal to what is the B? When it was when the charged particle could not be deflected in any field direction. So what condition is applicable where B is equal to what is the B? B is equal to E upon V hai, where E is called as the intensity of an electric field. Okay, this value substitute here. Therefore, the radial path is given by what is that? mv upon q into what is the value of B? B means E upon V हो जाते हैं, ठीक है, that is R is equal to mv square upon q into E. But our question is, we should have to calculate what is the intensity of electric field in the region. That is E is equal to what is the value of intensity of electric field in the region is given by mv square upon R into q है बेटा. That is all values substitute करो, इसमें क्या मिल जाता है बोलो. That is E is equal to m value is 1.6 into 10 to the power of minus 27. This is the mass of a proton, and V value was given 2 in 10 to the power of minus 2. 2 in 10 to the power of, sorry, V value was given 2 in 10 to the power of 5. 2 into 10 to the power of 5 of whole square upon R value was given 2 centimeters, that is 2 into 10 to the power of minus 2 into Q value also you know 1.6 into 10 to the power of minus 19 coulombs. Is it clear? Okay. What will be gets cancelled out? See here. Here 1.6 gets cancelled out. Okay. And this is what I am writing. See here, E is equal to 10 to the power of minus 27, 10 to the power of minus 19 gets cancelled out. So the remaining here 10 to the power of minus 27, 10 to the power of minus 19 gets cancelled out. Here 10 to the power of minus 8 is there, that is 10 to the power of minus 8 into, this is what is the value, 4 into 10 to the power of 10 upon, here 4 in 10 to the power of 10 upon 2 in 10 to the power of minus 2. 2 into 10 to the power of minus 2. Okay, is it clear? 2 in 10 to the power of minus 2. So 2 1s are 2 2s are 4. Okay, that is 10 to the power of 10, 10 to the power of minus 8 gets cancelled out. The remaining is the, what is that, where E is equal to, what is the remaining term? E is equal to, what is the value of E? E is equal to 2 into 10 to the power of 4 Newton for Coulomb. This much amount of the intensity of electric field we had applied before switched off across this system. Is it clear? Is it clear or not? बोलो, ठीक है. Next see, suppose consider a charged particle है बेटा. Charged particle means helium particle. Suppose consider a helium particle 2He4. This is a charged particle, that means helium particle or alpha particle. It is also called alpha particle. When an alpha particle is projected perpendicular to the direction of the magnetic field, like this, magnetic field ऐसे है, B into the plane है, that is B is equal to 0.1 Tesla, which is projected with a velocity of V is equal to, what is that, 10 kilometers per second. Then find the force experienced by the charged particle in the magnetic field. Magnetic field ऐसे है, magnetic field ऐसे है. This is the region of magnetic field. This is the region of magnetic field. ठीक है. This is the region of magnetic field. When a charged particle is projected like this, when a charged particle is projected like this, charged particle means when a helium particle is projected with a velocity of 10 km per second in the magnetic field of induction 0.1 Tesla, then find the force experienced by the charged particle in that magnetic field. Problem right now, find the force acting, find the force acting on the charged particle as shown in figure. How much amount of the force is acting on the charged particle? Okay, the force acting on the charged particle is equal कितने बेटा? F is equal to is already known, QVB into sin theta है. Where what is the angle of projection? The angle of projection would be equal to 90 degrees here. Therefore, what is F? F is equal to Q means what is the Q? Q means 2E into V into B sin 90 degrees. Okay, sin 90 degrees value is 1. Therefore, the force experienced by the charged particle in the magnetic field is given by what is that? F is equal what is the value of F? 2 into E value. E value is 1.6 into 10 to the power of minus 19 coulombs. V value is given 10 kilometers per second, that is 10 into 10 to the power of 3 meter per second. And the B value was given 0.1 Tesla. B value is कितने दिए बेटा? 0.1 Tesla. Okay. This 10 and 0.1 gets cancelled out. Remaining is the 10 to the power of 3 and 10 to the power of minus 19 is there. Therefore, the force acting on the charged particle is given by, this is what is that? 30 to 3.2. 3.2 into 10 to the power of 3 and 10 to the power of minus 19 is there. That is 10 to the power of minus 16 newtons. So, this much force will act on the charged particle when it is enters in a uniform magnetic field of induction. B is equal to 0.1 Tesla. Is it clear? Is it clear or not? Bolo? No doubt. Now, next concept, see, motion of a charged particle in a uniform magnetic field. Motion of a charged particle, motion of a charged particle, motion of a charged particle in a magnetic field, magnetic field, motion of a charged particle in a magnetic field. The force acting on the charged particle we can written as what is that? F is equal to what is F? F is equal to Q into V cross B hai. Okay. The direction of force we can calculate by using this is V cross B gives a force, that is V cross B, which is gives a direction of force. V cross B gives the direction of force. You should remember that. So, which is calculated by using the right hand form rule. The right hand is situated such that the first 4 fingers shows in the direction of motion or in the direction of velocity of the particle. If the palm, this is a palm, it shows in the direction of the magnetic field. Okay. Then the thumb is gives the direction of the force, right? By using the right hand form rule, we can determine the what is that direction of the force acting on a particle. How can I determine? See, a right hand is stitches such that first 4 fingers is stitches in the direction of the motion or in the direction of velocity like this. Okay. If the white palm is represent direction of the magnetic field, then thumb is gives the what is the direction of force. Is it clear? Is it clear or not? Okay. See, suppose consider a magnetic field here, beta. This is a magnetic field. Suppose consider a magnetic field. This is a magnetic field. This is a magnetic field having the magnetic induction B. Having the magnetic induction B, the field will acting. The field will acting inwards like this. The field will acting inwards. This is a region of magnetic field, uniform magnetic field here. The field is acting inwards, perpendicular to the plane of the paper as well. The field will acting inwards, perpendicular to the plane of the paper like this. Okay, is it clear? The field will acting perpendicular to the plane of the paper. It has a induction is B. Okay, when a charged particle of charge q, when a charged particle of charge q, this is a, when a charged particle, this is a charged particle here beta, it has a charge q and mass m, which is projected perpendicular to the direction of the field like this. Whatever this angle, here the angle meant by the particle with respect to the magnetic field is 90 degrees. When it is projected perpendicular to the magnetic field, what happening is there, perpendicular to the magnetic field with velocity v, this is with velocity v, then what happening is that when it is enters into the magnetic field, the force will act in upward direction. See, this is the direction of motion of the particle. Okay, this is the direction of the magnetic field. V cross B is gives a force. V cross B. What is that? V cross B. V cross B is the direction of the force. V cross B is gives the direction of force. That is V cross B. V cross B is gives the direction of the force. Everywhere the force will acting like this toward the center direction. So that's what happening is that the charged particle will move in a circular path like this. Okay, that's what the charged particle moves in a circular path. Where anywhere at this point, say the velocity will act like this direction. And what is the direction of the force? The direction of the force acts in toward the center direction. At this point also, tangential velocities acts along the tangential direction. The force will act toward the center direction. At this point also, what happening is there, the tangential velocity will act tangentially, but the force will act toward the center direction. At this point also, the tangential velocity will act like this direction, and the force will act like this direction. Due to that, what happening is there, the charged particle will move in circular path of radius r. कितने radius लगा दिए इधर बोलो? The radius of the circle would be p is equal to r level. This is a radius of the circle, small r level. Radius of the circle is a small r. Radius of the circle कितने बेटा? वो small r level. This is a small r. Radius of the circle is a small r. Let's take the radius of the circle is a small r. Okay. When the charged particle is here, on the charged particle, how many forces will acting? Toward the center direction, the one force is acting. That means the magnetic force. So away from the what type of the force acting? Centrifugal force will act away from this. Toward the center direction, magnetic force Fm will act toward the center direction. Okay. When the particle would be in the circular path, toward the center direction forces, away from the center direction force, at every point would be the equal. Okay, that means in this case, the magnetic force, which is equal to centrifugal force, both will be equal here. The magnetic force and centrifugal force both will be equal here. Okay, is it clear? Therefore, what is the magnetic force? F is equal to QVB, no? QVB, F is equal QVB is already know. F is equal QVB. This is a QVB. QVB is equal to QVB is equal to mv square upon r. Centrifugal force would be equal to mv square r. On both sides, what will get cancelled out? So V will get cancelled out. Therefore, r is equal to mv upon qb. This is called as a radial path of the charged particle. The radius of the charged particle in the magnetic field is given by r is equal to mv upon qb. Okay, what is its momentum? The momentum of the charged particle is given by, initially it is entered with certain amount of kinetic energy, k is equal to kitne beta, k is equal to half mv square. It is entered with a kinetic energy v is equal to half mv square. Therefore, the kinetic energy of the particle is given by ke is equal to, what is that, half mv square. This is what I am writing. K is equal to p square upon 2m. Therefore, p is equal to, what is that, root over 2m k e. That is, what is the p? P is nothing but mv, root over 2m into ke हो जाता है, ठीक है, 2m into ke. Now this value substitute in this equation. Therefore, the radial path is given by, what is the radial path? Radius of the charged particle is given by r is equal to mv. mv means p hai beta, p, that is root over 2m ke upon qb. Upon qb hai beta, this is a qb. This is the radius of the charged particle in the form of kinetic energy. The radius of the charged particle in the form of kinetic energy is given by r is equal to root over 2m into ke upon qb. Okay. Suppose if the charged particle is accelerated through a potential difference v and enters perpendicular to into the magnetic field of induction B. Okay. Suppose consider this is an, what is that, a potential difference V is created across this is a potential difference V is created like this. A charged particle is enters here. When the charged particle is enters accelerated through a potential difference and enters in a magnetic field of induction B, perpendicular to the direction of the field, perpendicular to the direction of the field. Okay, the field would be acting like this direction. Okay, the field would be acting like this direction in beta. Okay, if the charged particle would be moves in a circular path in the field with a radius r. Therefore, what happening is that here initially the charged particle has electrostatic potential energy. This is converted into in the form of kinetic energy Ke. Okay, which is converted in the form of kinetic energy Ke. Therefore, Ke is equal to EV naught hai na. Therefore, the radial path of the charged particle is given by, the radius of the charged particle is given by r is equal to root over 2m into EV naught upon qb. This is the radius of the charged particle in the form of potential. In the form of potential, the radius of the charged particle is given by root over 2m into EV naught upon qb. Is it clear? Is it clear or not? Bolo. Right. Note karo. Next, see, the radius of the charged particle in the magnetic field is given by, what is that, r is equal to mv upon qb. Okay, but when a charged particle is revolving in a circular path of radius r with a linear velocity v, about this axis of rotation, it has some angular velocity omega. Okay, so what is the radius of this circle? You don't know. Let's take the radius of the circle would be is equal to r. So what is the relation between linear velocity and angular velocity? The relation between linear velocity and angular velocity is given by, what is the relation between linear velocity and angular velocity? V is equal to r omega is already knows. Okay, V is equal to r omega. This value substitute in this equation, then you will get what is that, the radius R is equal to m into r omega, V is equal to r omega upon q b. So on both sides what would be gets cancelled? R gets cancelled. Omega is equal to qb upon m, where omega is called as a angular velocity of the particle. Okay, the angular velocity of the particle is given by omega is called qb upon m. But what is omega? Omega means 2 pi f now. 2 pi f is equal to qb upon m. Therefore, f is equal to qb upon 2 pi m. This is called as the frequency of the charged particle. The frequency, the rotation frequency of the charged particle in the magnetic field is given by, this is applicable in the magnetic field only. The rotation of the charge, the rotation frequency of the charged particle in the magnetic field is given by f is equal to qb upon 2 pi m. Therefore, how much time it will be take for the rotation? The time taken by the particle in the rotational motion is given by t is equal to, what is the t? T is equal to f upon f, 1 upon f. The reciprocal of frequency is called its time period. Therefore, the time period of the charged particle in that field is given by t is equal to f, 1 by f. But what is the value of 1 by f? 1 upon f value is a qb upon 2 pi m. This is called as the time period. That is, the time period of the charged particle is given by t is equal to 2 pi m upon qb. Time period means the time taken by the particle to complete one rotation. To complete one rotation के लिए how much time it will be take? T is equal to 2 pi m upon qb. This is called as the time period of the charged particle. Is it clear? Next, see, suppose a charged particle enters in a magnetic field. Suppose consider a charged particle which enters into the magnetic field like this, which enters into the magnetic field and rotating with an angular velocity omega around it. Suppose the charged particle has to be started point of A. Okay, again it has to be moved at point of B. It has to be reached at a point of B in t seconds, making some angular displacement theta. So how much time it will be take with respect to the whole time? With respect to the whole time. So let's take the total time taken by the particle to complete full rotation is the t है ना, this much है ना. So find the time taken by the charged particle to move from A point to B point. कितने time लेते हैं इधर देखो. So t by theta is equal to t by theta is equal to t upon 2 pi को बराबर हो जाता है. Okay, t by theta is equal to t upon 2 pi. What is the value of t? T is equal to t upon 2 pi into theta. Okay, but what is the value of t for the complete one rotation? 2 pi m upon qb. That is, t is equal to 2 pi m upon qb into 1 by 2 pi into theta. Okay, here, so here 2 pi will get cancelled out. Therefore, t is equal to m theta upon qb. This is called as the instantaneous time. Instantaneous time means the time taken by the charged particle at any instant of the time to travel on its circumference from one point to another point. From one point to another point is called as the instantaneous time. The instantaneous time is given by t is equal to m theta upon qb. M theta upon qb is called as, what is that called? Instantaneous time, where theta is called as a angular displacement of the particle to travel a certain distance. Okay, suppose if the particle has to be completed from A point to B point ऐसा complete हो गया, where A to A dash आ गए, theta is equal कितने हो गए बेटा? Theta is equal pi हो जाता है ना, वो pi हो जाता है. How much time it will be take? See, the time taken by the charged particle to complete a half circle है where theta is equal to pi हो जाता है. कितना टाइम लेते हैं ए टू ए डैश के लिए, कितना टाइम लेते हैं बोलो, टी डैश इज इक्वल, बोलो टी इज इक्वल टू एम पाई अपॉन क्यू बी. दिस मच टाइम इट विल बी टेक टू कंप्लीट द हाफ सर्किल. इज इट क्लियर? इज इट क्लियर और नॉट? बोलो, respond. Okay. These are the different parameters when a charged particle enters in a uniform magnetic field of induction B. Okay. Next see, suppose consider a charged particle है बेटा, इधर एक स्क्रीन लगा दिया, प्रॉब्लम से based on the concept एक प्रॉब्लम देखो, प्रॉब्लम जेई प्रॉब्लम है, वो जेई प्रॉब्लम. ओके, suppose consider a screen. This is a screen. At certain distance, one electron gun is placed. This is an electron gun. A electron gun is placed at certain distance from the screen. This is a screen here, beta. This is a screen here. Okay. This is a screen. This is a screen. Okay. At certain distance, at certain distance means at certain distance, I did place one electron gun. This is an electron gun. The electron gun will be project the electrons, which is placed at a distance of, at what distance it was placed? It was placed at a distance of r is equal to 2 centimeters. And between the screen and this electron gun, a magnetic field is applied like this. A magnetic field has to be applied. How much amount of the magnetic field has applied? The magnetic field, some amount of the magnetic field B is applied like this. Some amount of the magnetic field B is applied like this between the screen and the distance of electron. Between what did I do? A magnetic field of B is applied here. B is applied. Okay. When the electron is fired from the gun, okay, when electron is fired from the gun, it has to be comes and hits. It is deflected like this. Okay. It has comes like this, but it could not be touch the. It could not be touch the screen. It could not be touch the speed because of the magnetic field has to be prevents to touch the screen. The charged particle would be moving along the direction like this. Anywhere the charged particle is moving, anywhere the charged particle is moving, due to this magnetic field, the charged particle means the electron would be moving like this, and the electron is moving like this. Okay, it has a mass m and charge q. Then find the magnitude of the magnetic field to prevent the electron to touch the screen. Find the magnitude find the magnitude of magnetic field to prevent touch the screen as shown in figure. As shown in figure. As shown in figure. As shown in figure. Find the magnitude of magnetic field to prevent touch the screen as shown in figure. Okay, is it clear? Is it clear or not? Okay, how much amount of the magnetic field would be required to prevent the electron to touch the screen? How much amount of the magnetic field would be required here? See, when the electron is entering, it has some amount of the kinetic energy. Okay, when it is entering into the magnetic field, what happening is there? When it is entering into the magnetic field, what happening is that the magnetic field, the force will be continuously acting towards this direction. No, this is the direction of the magnetic field. This is a motion. This is a motion. No? Okay, everywhere what happening is the force will be acting like this direction. It has to be moves like this direction. Okay, the radial path is given by what is the radial path? Kinetic energy would be equal to what is that? The kinetic energy would be is equal to electrostatic potential energy को equal हो जाता है इधर. देखो. Therefore, the radial path is given by कितने बेटा? R is equal to, which is projected with certain velocity दे दिए. Half mv square is equal to कितने बेटा? Half mv square is equal to EV naught को बराबर हो जाते. From this, V square is equal to क्या हो जाते? 2 EV naught upon m है. V is equal to root over 2 EV naught upon m. So इतने वेलोसिटी से वो निकल जाते हैं because of which is accelerating between the potential difference of V naught. Okay, when it is fired, then what happening is there? This electrostatic potential energy gradually converts into kinetic energy. Beta, kinetic energy. Here it has a electrostatic potential energy. The electrostatic potential energy gradually converts into kinetic energy in the gun. That is, with what velocity it could be recoiled from the gun. So the charged particle would be recoiled with a velocity of V is equal to what is that? V is equal to 2e V naught upon ma. So with this velocity, the charged particle is recoiled from its gun. Is it clear? Therefore, when it is entering into the magnetic field, it would be deflecting the circular path. Means what is that? The circular path is given by R is equal to mv upon qb है बेटा, mv upon qb. But what is the value of V? That is R is equal to, यो eq लिखो simply. You should write same charged particle है ना, same charged particle है. Eb लिखो, Eb है mv upon Eb. That is R is equal to m upon Eb. V value is equal to root over 2e V naught upon m हो जाते. वो भी अंदर लेके जाओ. R is equal क्या हो जाता है? रूट ओवर m स्क्वायर इंटू 2 EV naught upon E square B square into m को बराबर है. This total term is takes under the root. Then these terms are will becomes like this. Okay. One m and m also gets cancelled out. Okay. And one e also gets cancelled out. The remaining term would be is R is equal to root over 2m V naught, 2m into V naught upon क्या हो जाते बोलो? E B square m. E into B I am writing like this. E into B simply. This B is writing, I am out of the root. E into B है बेटा. You see, this is what I am writing, E into B. Is it clear? E into B square है, B square. वो B square बाहर लेके जाओ. This is take out of the root. Then R is equal to 1 by B into root over 2m V naught upon E. What should we have to calculate? We have to calculate the B. The magnitude of the B is given by 1 by R into root over 2m V naught upon E. वो भी अंदर लेके जाओ. B is equal क्या हो जाता है? रूट ओवर 2m V naught upon R square into E. So this much amount of the magnetic field would be required to prevent the electron to strike the screen. Is it clear? Is it clear or not? Bolo. So this much amount of the magnetic field would be required to prevent the electron to touch the screen. Okay? Note down करो. Note down करो बेटा. Okay. Next concept, see, what is the next concept? Suppose consider a charged particle is enters in a uniform magnetic field, when theta is not equal to 0, comma theta is not equal to 90 degrees, comma theta is not equal to 180 degrees. Motion of a charged particle in a magnetic field when theta is not equal to 0, theta is not equal to 90 degrees, theta is not equal to 180 degrees. इस केस में कैसा चेंज हो जाता है रेडियल पाथ? देखो, सपोज कंसिडर ए मैग्नेटिक फील्ड है बेटा, जो हेडिंग लिखो, मोशन ऑफ ए चार्ज्ड पार्टिकल, motion of a charged particle in a uniform magnetic field, when theta is not equal to, what is that? When theta is not equal to 0, theta is not equal to 90 degrees, theta is not equal to 180 degrees. Okay. Suppose consider a magnetic field है बेटा, this is a magnetic field, ऐसे है, this is a magnetic field, this is a magnetic field है. Suppose consider a magnetic field like this, this is a magnetic field, this is a magnetic field having the magnetic field induction B like this. It has a magnetic field induction B like this. Uniform magnetic field here. This is a uniform magnetic field. Okay. Uniform magnetic field. It has a uniform magnetic field of induction B. Okay. Suppose consider a charged particle here, beta. This is a charged particle of charge Q and mass M. When it enters like this the field, okay, what happening is that the charged particle has to be deflects like this direction because of the force will acting like this direction. No? The right hand is stitches such that the first 4 fingers in the direction of velocity and the colored fingers give the direction of the magnetic field. The thumb is gives what is the direction of the force. Due to everywhere acting the force on the charged particle, what happening is that the charged particle would be deflects like this direction. Okay. When it is comes outwards, its path is nothing but a straight line only. Okay. When it is made some angle theta at this point, angle of deviation, this is the original direction, this is the original direction, this is a deflected direction. The angle between original direction to deflection direction is called as the angle of alpha. So alpha कितने हो जाते? With what angle? It would be made with the original direction. Okay, that is we should have to calculate now. Okay, right? How much angle it would be made with the original direction when it is emergence from the field? Alpha है, already we have taken alpha. From here से काम करो, here से एक line draw करो. Okay, it would be gives what is that radius of this circle. Let's this point is O as a center. How much distance it was traveled in the field? We don't know. Let's take it was traveled in the field is at a distance of x a beta. Okay, which is makes this angle alpha. Theta लो, this angle theta लो, this angle alpha ले दो, as alpha लो, कोई भी problem नहीं है. Alpha लो, और 90 डिग्री से, और 90 डिग्री और 90 माइनस अल्फा हो जाता है बेटा. दिस एंगल इज 90 डिग्री से है, वो क्या हो जाता है? अल्फा हो जाता है. वो एंगल क्या हो जाता है? इधर भी अल्फा हो जाता है. दिस एंगल आल्सो वुड बी अल्फा. So from this triangle it is very clear that, so what is the R? R is equal to mv by qb is already know. Sin theta is equal to what is the sin theta? Sin theta or sin alpha? Sin alpha is equal to कितना बेटा? Sin alpha is equal to opposite side by hypotenuse, that is x upon r. From this x is equal to r sin alpha. X is equal to r sin alpha. Is it clear? Sin alpha is equal to x upon r है बेटा. Sin alpha is equal to opposite side upon hypotenuse. So from this x is equal to r sin alpha. But sin alpha is equal to x upon r, you already know. Therefore, sin alpha is equal to x upon. So what is the value of r? When a particle is entered into the magnetic field, the radius of the path is given by r is equal to mv upon qb is already knows. Okay, this value substitute, that is instead of the r plus mv upon qb. Therefore, sin alpha is equal to, what is the value of sin alpha? X qb upon mv. We have to calculate the alpha. Alpha is equal to sin inverse. Alpha is equal to sin inverse of, what is the sin inverse? Where alpha is equal to sin inverse of x into qb, x into qb upon mv. So with this angle, it would be made with the direction of initial position. Okay, is it clear? Is it clear or not? So the angle made by the charged particle with initial direction to deviation direction is given by alpha is equal to sin inverse of x into qb upon mv. Is it clear? बोलो. Okay. Next देखो बेटा. Suppose consider a magnetic field है बेटा. This is a magnetic field ऐसे. The magnetic field is exist like this. The magnetic field would be exist like this. Okay. The magnetic field would be exist like this, perpendicular to the plane of the paper. The magnetic field is exist like this, perpendicular to the plane of the paper. And a charged particle is accelerating. This is a charged particle having the mass m and charge q, which is accelerating through a potential difference of V0 and enters into the magnetic field of induction B like this. Okay. When it is entered into the magnetic field, what happening is there? It would be moves in the form of a circular path. After emergent, what happening is there? It will be comes out in the form of a straight line and making some angle theta in the initial direction. Let's say theta. Okay. In this case, find the angle made by this charged particle with the initial direction. With the initial direction, with what angle it would be made when it is accelerated this potential difference. Already knows in the previous concept only. When the charged particle is accelerating in a potential difference of V0, it has the electrostatic potential energy. What is that? EV0 would be is equal to half mv square को equal हो जाता है ना? Is it clear? So what is the value of V square? V square is equal to 2 EV0 upon m, and V is equal to root over 2 EV0 upon m. So with this velocity, it would be enters perpendicular to the direction of the field like this. Okay. When it is enters perpendicular to the direction of the field with this velocity, it would be moves in the form of a circular path. Therefore, the circular path of the particle in this is given by, what is that? The circular path is given by the radial path or circular path of the charged particle is given by r is equal to mv upon qb is already knows. Okay. What angle it would be made? Which is made at an angle of alpha. How much distance it was traveled, we don't know. Let's take this distance would be is equal to x and the radius would be is r. Okay. From this triangle, what I am writing? Sin theta is equal to x upon r हो जाता है ना? Okay. Sin theta is equal to x upon r. So from this sin theta is equal to x upon, what is r value? mv upon qb है. ठीक है. और sin theta is equal क्या हो जाता है बोलो? x into qb upon mv. But what is the value of v? This is the value of v, no? With this velocity it was entered, so that value substitute here. Therefore sin theta is equal to x into qb upon m into v value is root over 2 ev0 upon m हो जाता है. So theta is equal क्या हो जाता है बोलो? Sin inverse of theta is sine inverse of x into qb upon m into root over 2e into v नॉट अपॉन m हो जाता है बेटा. इसको एक काम करो, वो भी e लिखो. This value also you should write e only. This value also you should write e only. Or theta is equal to sine inverse of x into this value root e into root e लिखो. Root e into b अपॉन m अंदर लेके जाओ, क्या हो जाता है बोलो, m अंदर लेके जाओ, दैट इज रूट ओवर m स्क्वायर 2e नॉट, ओके, अपॉन m. One root e gets cancelled out here, one mm gets cancelled out here. So this is the angle made by this particle with respect to this original direction. Okay, is it clear? Is it clear or not? Okay. Today concept, do you have any doubt? Please ask me on the scrolling number. And unmute your Zoom and you should ask your questions. Do you have any doubts on today concept?